Hello friends, welcome back to our channel. My name is Sandhya Seth and today we are going to talk about Rutherford alpha particle scattering experiment. So let's begin. Now, first we will discuss about what was his discovery of nucleus. Ernest Rutherford, he was a scientist in 1911. He gave the concept of nucleus based on the result of his experiment known as alpha particle scattering experiment. His experiment was known as alpha particle scattering experiment. Rutherford bombarded a thin gold foil with alpha particles. The foil was surrounded by a spherical screen of zinc sulfide. The alpha particles were condensed to a narrow beam by passing them through a pair of positively charged parallel plates. In his model, he put alpha particles in a gold foil. He put his alpha particles in gold foil. Like I will show you how. First, here there are so many particles. And in between there is neutron. And then these particles spread it in two parts. This is like this. Suppose this is some particle, and now here again some particles. This is alpha particles, and this is lithium particles. Alpha particles are alpha rays basically. They consist of two protons and two neutrons. Consist of two protons, two neutrons. This is alpha particles are made of. Moving on to our next thing. Now we'll see the observation of his alpha scattering experiment. From his experiment, he saw that most of the alpha particles passed straight through the gold foil. Suppose here is a gold foil. Let's say here is gold foil, and here is he put alpha particles, and he saw that most of the atoms passed from it. This proves that atoms must have large empty space. If they pass, this shows that atoms have large empty space. This was the first thing he saw. Secondly, he saw that only a few alpha, like most of them passed from this, but only a few alpha particles were deflected through small angles and a few were deflected through large angles. Like everything passed, only just suppose this is a few particles stop here, they couldn't pass. Very few, in like 1 in 20,000, alpha particles completely rebounded. Very, very few. Can you imagine 1 in 20,000? It's very less. They completely rebounded. So this was the observations he saw from his model. Now we will see his Rutherford's atomic model. What does the atomic model consisted of? Atom consists mostly from his observation. We saw that atoms consist mostly of empty space. The entire positively charged particles, which are protons, are present in center. Here they're present in the center of atomic sphere. This concentrated positively charged mass within the atom is called nucleus. Suppose this is an atom. In the middle it's nucleus, and around it it's proton, P, positively charged particles. The size of the nucleus is very small compared to the size of the total volume of atom. Nucleus is very, very small. The electrons within an atom must revolve around the nucleus at various various distance at very high speeds in order to counterbalance the electrostatic force of attraction between protons and electrons. Protons and electrons must revolve. Like here, suppose you can see they are revolving in this. Wait. Here you can see that they are revolving. Protons and atoms are revolving. Now we will see some drawbacks of his atomic model. Drawbacks, it simply means limitations, or what is a mistake. Rutherford's model, it could not explain the stability of an atom. It can't explain the stability of an atom. Electron is charged particle moving around the oppositely charged nucleus. That means electrons move around proton, because electron is negative and proton is positive. So oppositely charged. So in the nucleus they revolve around like they're differently charged, so they revolve around each other. According to classical electrodynamics, an electrically charged particle revolving around in a circular path radiates energy. This radiates energy continuously. It radiates energy continuously. So hence, an electron revolving around the nucleus should radiate energy and gradually move towards the nucleus. So in this, if it if it radiate energy, it should move towards the nucleus. But in his model, it wasn't happening like this. In his model, everything was just revolving. Nothing was coming closer to the middle thing, nucleus. This gives a spiral path for electron, which would finally collide with the nucleus, and the atom would collapse. But atoms are quite stable. Like if they are moving, they should collapse. They're not coming in the center. So this was a drawback of his. So we are done with the Rutherford's atomic model, or the Rutherford's alpha scattering experiment. So thank you for watching our video. Never miss out on a new video, and subscribe to our channel. If you have already subscribed, do watch our upcoming videos. Thank you. Goodbye.